What is the most used man-made material on Earth? You guessed right. It's concrete. Look around. It's everywhere. Sidewalks, driveways, foundations, floors you stand on, and even entire buildings are made out of concrete. So why don't we discuss it more? In each episode of Concrete Logic, we will explore one concrete-related topic with the help from industry professionals that are shaping the future of the trade. We'll talk with suppliers, contractors, architects, engineers, specialists, and even some proponents of competing materials about their views of concrete and their vision of its future. And welcome to another episode of the Concrete Logic Podcast. And today I have Stephen Ostrowski with Trimble. And we're going to talk about 3D scanning and how that relates to concrete. I'm excited to finally get somebody on here to talk to me about this. Stephen, do you want to give the folks a little bit about yourself and your company?
Yeah, hey Seth, thanks for having me. So I'm Stephen Ostrowski. I am the scanning and kind of mixed reality guy. I used to be product for what we have as the X7 laser scanner. Moved to sales when I actually realized how easy it was that even I could sell it. So the X7 laser scanner kind of works with the same tablet and software that runs the Trimble robotic total station, which is pretty synonymous in most construction with the line and grade teams setting up and staking out. But instead of laying out and collecting 1 point at a time, a 3D laser scanner will collect a couple million points in a few seconds. And I've really taken a focus on the concrete industry because with scanning, you can actually now see live where the screed might be off if you don't have line of sight to laser and where things aren't going down flat. So I've been on many pours in the middle of the night trying to show, generally it's the line and grade team or the GC who's there, but hopefully moving it more into the foreman or the finishing crew to kind of see the work they're putting down and hopefully fixing those problems while it's still wet and workable. So
yeah, that's really cool. So we're gonna have to educate some folks because some people that listen to this podcast aren't as well versed in concrete and layout and all those things you just shared with us. So let's go back to layout. So right now, or not right now, but a kind of a standard way of doing layout. You have a guy that's on a instrument, a total station, and he's looking through usually there's maybe one other guy on the other end, and he's got a prism, and these guys kind of use this machine to go around and pick out points around and do basically what they're doing is taking a 2D drawing, a paper drawing, and they're laying that out in the field. And what Trimble and I would say concrete folks on the cutting edge, what we're doing now is we're using, like you mentioned, Stephen, a robotic instrument where it only takes one person to do the layout versus two. And it's the same kind of total station machine. Instead of having someone behind that machine now, that machine kind of moves on its own, right? It kind of swivels around and follows the guy around when he tells it what points to lay out. Did I say that right?
Yeah. So Trimble if we have software, and some of your guys might know this from estimating or like Tekla for concrete and steel design. But really, what we sell survey hardware. So we sell traditional GPS and total station or measurement equipment to what used to be surveyors and now are concrete guys. And so when I say the robotic total station, one guy is able to lay out or essentially put the edge of concrete or anchor bolts or whatever was designed, put it in the right spot in the field. Usually they do this because it reduces the number of guys to do this, increases the accuracy, and actually increases their speed. So that's where Trimble has probably been around construction industry for 10, 15 years, and a lot of the guys who are on the line and grade team, a lot of times are former surveyors who are helping to set up the project, right, before they actually start putting in the concrete. So we're the interface between the digital and physical world as far as the sensors or measurements that are able to do that. And yeah, hopefully that makes it a little bit clearer.
Yeah. And then I'm trying to think what the next step was. So the next step, I think, we went from robotics to, I think, wouldn't you say, Stephen, we've gone to the 3D models. That's when the building information modeling got involved. And that took the drawings and made it into a 3D object that you can see on a screen on a computer. I think that was the next evolution in field engineering or line and grade layout. Is that
Yeah,
correct?
I mean, you do see people bringing in models. I will say, at least what I focus on, especially for concrete, is generally just 2D or flat work. You need a finished floor elevation to get the volume, but people will now, lay out to a 3D model that's been designed through and through. But a lot of times that enables prefab for a lot of the sub trades when they do that coordination model. But what I actually like to work on and the problem I like to solve is either bringing in a PDF or just not having any data, essentially just setting an elevation or a relative elevation to make sure it's flat. Essentially simplifying, not speaking to the full coordinated model, because a lot of times that's not needed. It's not on site. Putting down either flat concrete or things in the right spot is just what we're trying to accomplish. So
Yeah. So once things are put in a spot, say, so the engineers lay everything out. Say you're laying like a column or a floor, and you want to check to see if those specific items, objects, are in the right spot. And that, I think that's when we get into talking about 3D scanning, right?
Mm-hmm.
So once you have that concrete column in place or that concrete floor in place, mm-hmm. or even, and what we're going to talk about here in a minute is during those operations, which I'm excited to hear about. But what we're doing with this 3D scanning machine is it's a machine that sits on a tripod, just like the total station and the robotic station and all that stuff. And it goes around and it scans everything around, right?
Yeah.
It scans in 360.
Yeah, it takes a
degrees.
panorama 360 image. Is kind of how I like to describe it. But behind that image is essentially a bunch of measurements up to 80 meters or 260 feet or 240 feet with the same accuracy as the total station, so about a 2 millimeter accuracy. So essentially it'll grab everything it sees, and then what you do is you just pick it up and you move it again, and it'll tie back to that previous scan. That's called registration. As long as there's a little bit of overlap, it'll tie those together, and then you'll have an as-built. Essentially, it's what we call a point cloud. So many measurements that you can define what everything is, an anchor bolt or anything else that's there. And you're able to register those scans together, collect multiple scans, and then georeference or compare them back to a model or PDF on the software, so you can actually see if that column has been put in the right spot or if your stairs are going to fit, right? So that's the as-built measurements that go pretty quickly, and it's actually all done the same system or the same software and the same workflow as your total station, but with just more data. So
yeah, a lot more data, because before we started using that technology, I was a field engineer at the beginning of my career. So we used to have the two guys go out there, and you would literally hold the prism in a spot and take that measurement, find the coordinates of that spot, and you would do it,
you better
couple dozen times, but there is no way you're doing it as much as that robotic.
Yeah, and you better have good field notes, because if you don't write exactly where you took that measurement, if you did an offset, you have no idea, right?
So we've gone light years beyond that. So now we're taking, like you're saying, millions and millions and millions of data sets that's being collected with this scanner, and it's essentially when it's creating a 3D model of the existing conditions, right? Is that a good way to put it?
Yep, perfectly. So
Yeah. So you had the as-built condition to, you were saying, within a couple millimeters.
yeah,
Is that?
eighth or 16th. It kind of depends on your survey practices too. So the scanner will use a laser pointer like your total station, and with surveying, it depends on workflows and best practices. But most people, yeah, a quarter inch is the worst. Usually an eighth or a 16th. You can kind of get the measurements too. So
Yeah. And so, and what I've seen in the past, Stephen, is you can actually go in there, and I'm not well versed in with the different software you use, but you can go in there and put in your concrete tolerances and tell it what your tolerances are.
yeah. So the scanner will self level, so it'll just start off by itself, and it self levels to 3 seconds. So if you're looking at your tolerance as far as up and down, you can just look at an elevation map, and it's going to show you red is high, blue is low. If you have to be within a quarter inch over 100 yards, you're going to see where you need to flatten it off. If you didn't pour enough concrete, generally it's a little bit harder to add more. But if you're high, you can always bump cut it. So you can just view it right there, and hopefully within 3 to 5 minutes, actually see that data, and then fix the problem that will be there. Most of the time, as I've been on a concrete pour, 95% of a floor goes great. The screed will always have good line of sight back to a laser, right? But then it's the last 5%. And that's usually what defines the floor as being bad, is the bad spots.
Mm-hmm.
And that's what this is able to catch very easily and very quickly, as far as seeing that. So
Yeah, so what Steven's describing is during the concrete pour, a floor pour, is we use a machine, a laser screed, that it's a machine that it's taking data from another laser, and it's leveling based on where that laser is. So the machine knows where it needs to push the concrete and level the concrete.
Keeping it at a set elevation, right? And
Yeah.
then rather than having a bunch of guys doing it manually, this kind of does it automatically.
Yeah.
You have a bunch of guys doing it manually, you can do the same thing, but generally when you're putting concrete down or something flat, you just want to keep it to a certain elevation, have it all be there. A lot of times now they'll pour 25, 50,000 square foot, and they'll be really spot on by just doing that and having a couple hundred trucks come in, pour some concrete down, but there's always bad spots. And usually, depending on the client, they will want it flat for different reasons to make the rest of the building go smoother. So the concrete guys are in and out generally pretty quickly, although cost-wise, it's a third of most projects is what I've heard. But the rest of the subs that go in after it may require that the floor be flat for whatever they're putting in. So what we're trying to do with the scanning is make sure everything's in the right spot, so that goes in a little bit faster, but then also make sure that everything is also flat or vertical. If you're looking at a elevator core, you can do the same thing, or a stair core, just with this as-built measurements. And my goal really with the scanner, or with what the tools we have, is to be actionable when you actually look at that data. So if you're putting a elevator core up and you keep moving up, you want to make sure that you're not leaning or going in and out, and you're staying within tolerance vertically, and our tools help people do that.
Yeah, no, it's really, really cool, especially if you can get real-time data, because before that technology was available, what would happen is you pour the floor, and then it would cure, harden up, and then you would there was an instrument that you manually walk across the floor, and we call it walking the dog, and it basically takes measurements of the ups and downs of the floor, and there's tolerances that we have to be in, and like Stephen was sharing, depending on the customer, it can be not so hard to make those tolerances, and then you got some customers like an Amazon that it's pretty high, a high bar to hit as a finisher, to match those tolerances, and that it's the floor flatness. And go ahead,
Oh,
Steve.
yeah, sorry, I didn't even realize that's the tolerances you were referring to. So, the FFFL, or floor flatness and floor
Yep.
levelness.
Yep.
We can do the same report. Now, usually what will happen is there'll be the GC and concrete, and then a third party will do this report using another instrument called
Right.
like a dipstick or an F meter. And they just take a measurement every 1 foot and compare those back to each other for floor flatness. And then for floor levelness will be over a larger span. And we can do that live actually with the scanner and the software in the field, so you can get an idea of your FFFL. Um, Usually what will happen, you still need the third party to contractually sign off on what's good and what's not. But the concrete contractor or the GC can look at what their floors will score right there. So they'll have that written out in the spec of, depending, most floors, a lot of the larger floors will have it just to make sure that you're not getting back kind of a wave pool. They want to make sure it's pretty flat. But then as you go into certain warehouses or data centers or hospitals, they need it to a certain flatness spec. So we can do that, draw the lines the same way and actually replicate what the D meter or F meter will want. But usually what I try and preach is even before you get to that part, which is you're generally doing that after you're floating it. When the concrete's really flat and it's a little more difficult to work with, I'm trying to tell you to scan even before that too, so you can make sure that you can still hit those numbers. Generally, your FF or your 1 foot won't be really great until you actually float it, but you should be able to catch your FLs if they're bad, and you can your finishing work and the guys who are out there are riding on the trails and then floating it. They're the guys who can get you the really good FF or essentially smooth, but the FL is usually dependent before that, which is how level that concrete goes down, which involves the trucks and the movement of a lot of material and putting it down well. So
Yeah. So what you're helping concrete contractors do is prevent what typically would happen is if you don't meet those requirements, then there's more work to be done to get it to those, and it might be leveling it with another product, or it might be rip it out and redo it, depending on what it is. So
do you guys have to grind ever too? Or
grind,
grinding or hard deck, right? So that'll always cost a lot more. And
yeah. So doing it during the pour, which prevents that rework, so you can work, know what you're putting down and know where you're at before that concrete sets up, and where you need to, what areas you need to bring up or bring down to meet those tolerances. So that way, when you walk away from the pour, you know that you're good. And so when that third party guy comes back the following day and does his measurements, you're confident. And usually, if everything works out well, right, Steven?
Yeah, and you can usually tell them where to test too. I mean, they know they're going to do what the test says, which is well distributed. But you can even if you fail one line or a local, you can actually show the owner like, hey, the rest of this floor is great. This is a reason why this area didn't go well. There's a lot of stub ups or whatever it is, and generally you can still get it through. But my other goal with it is after you're done, you have a timestamp, right? Your concrete's going to cure. It's alive. It's always moving. It's right. It's a living organism that's kind of getting rid of some moisture. But you have a timestamp of what you handed over at the end of that pour, and generally within 3 days, that's when they have to test it. And ideally, you shouldn't have to drive back out to the site when the framer's going in and his door keeps hitting, right? He goes to open up a door and it keeps scraping along the bottom, where the GC might call you guys back to try and flatten it out or say this wasn't good enough. You actually can say, like, no, it was when we were done and we handed it to you. So there's no more trips back out or repetitive trips back out to the site. And so that's the other big sell with it too. It's just concrete guys you got to move on to the next pour, and generally you're off a job and on to the next one too. GCs will stick around and kind of hold that money too for a while. So if you have a snapshot of what's there, you know what you did was good too. So
Yeah, because what Steven's getting at is once you put the concrete down, if say the engineer didn't take into consideration deflection, the weight of the concrete can make on an elevated, say a steel floor, a slab on metal deck is what we call it, and that floor deflects after you put the concrete down. That's no blame to the concrete contractor. It could be the engineer's failure to recognize the weight of the concrete, which usually good engineers, good structural engineers, they'll have they'll actually tell you in the structural drawings how much that floor is going to deflect. And that's where the live 3D scanning is pretty cool, because what guys can do is load that floor with wet concrete and go work another area and let that floor deflect like the engineer said it's going to do. And then they can go back and hit it with the machine, and you can tell them if they're hitting those floor flatness, right?
Mm-hmm. And then on grade, you'll still see a little bit of the curing on the edge, right?
Some curling could happen.
Curling.
But and again, but to me, a concrete contractor's got more control on the slab on grade than he does versus what happens on an elevated steel deck. Obviously, it'd be different if it's an elevated structural concrete floor, then that's all on the concrete guy. But on a steel building, on a slab on metal deck, like you see in these large distribution centers, that should be top of mind for any concrete finisher out there and concrete contractor, is how much is that floor going to deflect?
Yeah.
It's not like a slab on grade where you go out there and you're just plowing through that slab on grade and you're just truck after truck after truck. You're truck dumping on a slab on grade and things are going great. On a slab on metal deck, it's more meticulous, because you gotta be aware of that deflection. And that's where I think that technology is really cool, where you get the live feedback from a 3D scanner. It says, hey, that deck has deflected. You need to go back and fill that hole.
So yeah, the scanner seems to be taken up. Like I'm at Columbus, Ohio State. Been on actually, they're using it there for that example. Most of the pours I've been have actually always been on grade, because those seem to be the higher spec floors. Because obviously you can't spec a contractor when they're going up, because you're relying on the engineer and the steel to be there. So
but they do.
The specs aren't. Yeah, they do. Sometimes the specs they throw on these, I feel like they don't know what they're asking for. They just throw out a number, and it's up to the concrete guy to be like, this isn't reasonable, but you also need to do the work. But a lot of times I'm out, it's usually on grade data centers or distribution centers like that. Or the dozens of pours I go out to a couple times when they're going up. But
that's where I think you could help out a lot, Stephen, on those elevated floors. I'm not saying that the slab on grade or the slab on ground isn't helpful, but the elevated floors, in my experience, those are the ones that are tricky. And there's still some, top clients out there that require a pretty high level of FF and FFL numbers on those elevated decks, because they got robots going across those floors. The robots don't like the wavy floors at all.
No, they need it flat. And we have customers doing it. Just, my experience has been limited to the other side, which is always the super high FFFL numbers lower. But yeah, I'll actually try and make it out to some of those larger distribution centers and going up. The other thing I always see is elevator shafts or stair cores. But usually those are not what I love about scanning. It's finding the mistake afterwards and who's responsible and where to fix it, which scanning will do. I like to find the problem while it's going on so you can fix it while it's going up, because generally I could see the tool being used more widely there, which obviously is my end goal, is to have it everywhere. But for the elevator cores or stair cores, when you can actually see them move in and out, that's a lot of times when I come out to show people.
Yeah, no, that was my first interaction with 3D scanning was scanning walls and finding out where they were, because it's a long story and it's kind of funny, but I'll save that for another time. But the cores are a big deal, because if you're going up 12, 15, 20, 40 floors of a core, you can't be at, again, that has pretty strict tolerance because of the elevators. The elevators, the railings and things can for the elevators.
They still work on gravity, so you can't go too much in and out.
Yeah.
So you get like 1.5 inches, something like that for tolerance.
Yeah, like you said, but unfortunately, I think for most part right now is you're finding out after the fact that there's a problem. Versus, I was thinking maybe if they could, maybe there's something out there, but if you could put on the formwork as you're climbing it up, if there's somehow to put like some kind of prism or something on four corners of that core, and then you had these machines that were kind of tracking those, and it would kind of beep or yell at you, or you get an alert on your phone or something if that thing is not where it's supposed
going
to be.
up all the way. Good surveyors will do that, right, and be able to follow it. But you have to know what you're doing in processing to transfer that up to, which not everyone has sometimes the ability, and there's a lot going on with most of these projects, right? So you just kind of lose it every once in a while.
Yeah, but I think because there's good and bad field engineers out there. So some of them are like, I can get that thing to come back to where it's supposed to, and all of a sudden you're 12 floors up, and that thing is out of tolerance, and you're in trouble because you're running out of floors to get it back to where it needs to be. Yeah. So if you had something that had that control and everyone was aware of it, because like you said, where people make mistakes, and but if you had something that everyone, like the superintendent or even the general contractor, was aware of where that thing is and how far it's within or out of tolerance.
And that's really, I would tell you to take a look at it with the scanner and then doing it on the tablet. It really is about that easy. To really tie it back into control, you will need to have some of that spread throughout or from your surveyor. But with the X7 and FieldNeg, it kind of matches its own puzzle pieces, and then you can see that real-time comparison there. As long as you have the control on each floor that you can bring in from the surveyor on site, you can generally tie it back very easily and quickly. So well, cool. Well, I think we beat that up enough. Before I let you go, I wanted to talk to you about the augmented reality. I mentioned that before we hit record that I was having a conversation with a formwork supplier and asking them if we had any augmented reality technology out there for folks that put up formwork. A concrete contractor put up formwork instead of the way we do it now. But I saw a post on LinkedIn that you all had up there showing something with MEP. Can you, can you talk to where the augmented reality is at this point? Yeah. So with scanning, you're going to bring in either a PDF or a model. You can scan and compare the as-built to the model down to an 1/8 inch or so. With the augmented reality, that's using an iPhone or an Android phone or tablet. And what you can do is project the model in a 1-to-1 scale, or in a PDF, you can scale it so it actually sits on the ground. And what happens is as you walk through the site, because your phone or tablet has a camera and a couple other sensors, it knows where it's at, and it'll actually update the model, so it'll overlay everything that you're trying to build on site. It doesn't have the same level of accuracy. Obviously, if it did, you wouldn't be Trimble wouldn't be as big as we are. We wouldn't be selling all these other instruments that are a little bit more expensive, but it gives you great context in what you're building. And if you can overlay the model for formwork or the PDF or what's going up, you can kind of place it a little bit more efficiently. And anyone on site can generally use this stuff. It's just like using your phone for any other game. It just kind of aligns it, and then you walk through. If you see an issue, you can either FaceTime someone in and share your screen, or take an image or what we call it to do and share that back, so that you can either show someone else on site or ask the guy back in the office, hey, does this make sense what we're trying to do? And it's just trying to bring that 2D paper plan to the 3D site very quickly and easily, which it does. And then it just runs through an app. So if you get an email of a PDF of that formwork plan, you can pretty easily project it and see what's happening and whether or not those stairs or that ADA ramp or whatever might be in the way is should be there, or we have the wrong plans or whatever. So
yeah. So what I've seen this a couple times, and like I said, I checked it out your post this morning. So it looks like what you do is you scan a QR code, right? And is that QR code then a control point on the job site?
Bunch of them here before I painted the office. It's essentially a control point, right? You would measure it in if you wanted to be really accurate with the total station, and you could use it to actually measure to set up your total station later, and hopefully automatically set it up in the not too distant future.
Oh,
but
cool.
It's just a point on site, right?
Mm-hmm.
This is going to be like a control point that it will recognize, or you can manually tell it where you're standing, mm-hmm. right?
So the YouTube that I saw this morning, the guy scanned the QR code, and then it looked like on the screen, the iPad or tablet, whatever he was using, knew where he was on the job site. And then as he was looking at the iPad, it was showing him what was supposed to be there, right?
Mm-hmm. Mm-hmm.
And so does it tell you, like, is it just like looking at a 3D model that is within the tablet and it knows where you are and you're moving around?
Yeah, as you start walking through, it'll keep updating the site with what you see, and you can see through the model, and you can turn layers on and off. Obviously, when you move away from where you set it up, a couple 100 feet or more, you'll see drift, and then you can either scan another QR code or manually bring it back to make sure that the model realigns. But you'll see, like, usually what I encourage is have a little bit of architecture in what you're looking at, and then have like the stair or the steel, so you can always make sure that the steel model matches with the steel in real life, and then you'll see the MEP stuff going through or whatever. So if you put it in your pocket, it's going to lose tracking, but if you kind of walk it through, it'll always maintain it and be pretty good. So we have a couple large GCs that'll use this for checking what's going up. And then my goal is to really just have those QR codes everywhere on every site where someone could scan it. I mean, this is the end goal. Doesn't matter who you are, you could scan it. It'll bring you to the model that should be there. And then any laborer or anyone doing essentially anything on a site can actually get context of what should be there and what shouldn't, and what they're trying to do, right? To hopefully reduce rework, which is just the name of the game, and get off the site faster.
Yeah. So at this point, it's just taking the model and putting it out in space in front of you, right? It's
mm-hmm.
not telling, at this point, it's not telling you, hey, this is in the wrong spot. It's not screaming at.
Yeah. No, you just got to visually be able to see that. I mean, with scanning, we can do a scan to model inspection on the tablet where it'll actually do a heat map of where things hit. But with the AR, we haven't quite done the automatic, hey, this is wrong, or maybe I should ping that. But yeah. That's the IoT of things, and kind of, I'd say, the more forward-thinking tech that should be there one day, right? Yeah. It doesn't seem like it's too far off, but usually those things are always a little bit farther than you think too. But hey, I moved on from product. I don't really know what's going back on the development side. I know what we have currently today, and hopefully one day I come in and they tell me, hey, we have this now, and I go, oh, that'll be really nice for everyone out there. Yeah.
No, I think it's really big. The augmented is really big, just to I think before whatever's installed, like mm-hmm. the MEP one, before the MEP is installed, the guys can see what's supposed to be where they're standing, what duct work, what conduit and all that stuff,
Yeah.
and who goes first, who goes last.
It's always who, yeah, with our stuff or most projects, they'll lay it out or they'll put their sleeves and bang it so that they know where to put their stuff, but it's always an elevation problem, like who's putting it in first. Like if I put the HVAC, can the plumber get to where he needs to? And if you could view that, you know the schedule and order of things, which is huge. And a lot of times where guys will make mistakes, or not guys will make mistakes, just where projects kind of get off tracks a little bit there. So I've been on plenty of job sites where that happens.
Yeah, could you, I assume you could do this. Could you, okay, say it's a structural concrete floor, and before you pour that floor that's above your head, before you pour that floor, you go up on that deck, on that formwork, scan all the PT and rebar, where it's at, and then have that information in the cloud or wherever it goes, right? Go ahead and pour that floor, and then when you go back down to the bottom of the floor, or the floor below, and the MEP guy, which is our concrete guy's favorite thing that they do, they put screws and blasting all kinds of things to install their ductwork, their conduit, and whatever else, lights and all that stuff going through that deck above. And the GC always turns to the concrete guy and goes, "Hey, where's your PT? Where's your rebar? So we don't hit that stuff." And you're like, yeah. And right now what we do is on the formwork before we pour, we'll actually take chalk or and mark where it goes. So then when you pull the formwork off, you see those marks on the concrete, and then the guys see it now. But I assume now we could use that information.
So the goal, what you can do and what some guys will do is, they'll scan before to capture where all the PT cable is. Yeah. You can compare back to the model, see if it's moved at all. But because the scan is, you would cover the whole deck, they'd register in georeference. Because it's georeferenced or it's tied to coordinate space, after the concrete goes through and is poured, you can always go below and just relay out where exactly that PT is coming, either using the same tablet in X7 or laying it out with your total station. So you can tell the guy where he missed a sleeve, where he can go up, right? Usually especially if they're doing those decks, they're hoping they're putting their sleeves in before. But if they get moved or if they missed them, you know exactly where the cable is. So those guys can core. And it's, how do you share that from the tablet? You can either show it to them in Field Link or give it to them or you can convert it to a layout point and share that with them, or you can just give them an RCP or a recap file that they can bring into Revit or CAD, and they can design where their new tie-in points or hanger is going to go. It's really, really pretty easy when you're always living in the correct coordinate space. You can share that information a couple different ways and pretty quickly. So the important thing is just scan. Gather it before you cover it up would be the first thing, because if you don't, you got to come back with the X-ray machine, and those are expensive, right? Be harder to get out and not nearly as accurate. So if you can do that before, you'll be better off.
Yeah, collecting as-built information and collecting as much data as possible. So that applies. Collecting as much data as possible applies to concrete construction. But
you gotta. We always. That's one of the drawbacks of scanning. Is it's so much information. So you want to make sure it's actionable and you have your processes set up so you know where to pull it from and how to use it most efficiently. Which I think we've actually solved most of the problem there. So
this is awesome. I appreciate you coming on the show today and sharing this stuff. I think this is a good spot to stop today. I could probably talk to you for another hour about this stuff. I like the field engineering layout stuff. So, Stephen, if folks want to reach out to you and learn more about what you're doing and what Trimble's doing, what's the best way?
YouTube, online, LinkedIn, any of those. So I work for Trimble directly, but we have a big distribution channel called Building Point 2. They're your local guys who can get out on site and actually show you how this stuff works, which is my preferable way to do it. But if you want to send me an email, it's just Steven_Ostrowski, and hopefully it'll be in this description for my spelling of my last name at trimble.com. I'll be happy to talk to you about any of the things we discussed today. And then if you want to see it on site, either I'll be there or someone who I work with can come out and show you, because that's really the goal, right? Is showing you how to use this stuff.
Yeah. No, we'll get all that contact information for you in the show notes, and people will know how to get a hold of you. Steven, I appreciate you coming on. Appreciate it.
Hey, no problem, Seth. Thanks a lot, and I'll see you next time you're back in Ohio.
Yeah, man.
All right.
Thank you for joining us for another Concrete Logic podcast episode. If you got some value out of this or you enjoyed it, please share it with others. And if you could take a moment and give us a 5-star review on your favorite podcast listening app, I would appreciate it. We will catch you on the next episode. And now Mike Dunton's going to take us out.
Ring, ring, that alarm always sings. Couple hours before the sun comes up. Open up the side, put some diesel in the lights, and wait till the trucks roll up. Yeah, this ain't how most folks live their lives, dripping in sweat, working overtime. But while they're tying their ties for their 9 to 5s, we're out here changing these skylines with wood, iron, and mud. We work hard for $1, give thanks to the Lord above. Something you can't prove. Hard work calls for a drink or two. Expect more, it's written in our blood. With wood, iron, and mud. From the swamps to the city, from the Lone Star heat to the woods of the Georgia pine.